Switch up the last video, but unfortunately I didn't realize how loud the background would sound, so I have to redo it. Hi everyone, I have question 8 of chapter 15 asking what alkene with these reagents would produce the secondary alcohol. So since they've given us the final product, they haven't given us the starting product, we want to work backwards to see how exactly can we predict the final product. Now looking at the first, well, the last, but for us it's the first since we're working backward. The first reagent, this would attach an alcohol to an alkene. So how we're going to undo this is we're just going to draw the compound without the alcohol, and then we're going to attach the alkene. The alcohol usually attaches to the more substituted side of the compound, but we're not entirely sure where exactly that is because they're both equally substituted. Okay, so the second reagent we have is lithium over ammonia, and what that does is it donates electrons and deprotonates, it reduces an alkyne to an alkene. So actually it doesn't deprotonate, it actually protonates it. So if we're going to undo it, we're going to get an alkyne now. Since we have 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oop, is that 7? 1, 2, 3, 4, 5, 6, 7. I'm sorry. 1, 2, 3, 4. Wait, 1, 2, 3. Okay. 5, 6. 1, 2, 3, 4, 5, 6, 7. Oh my goodness, I'm really sorry. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, finally. Sorry for that blunder. So that's what the second step did. Now the third step, it attached 2 carbons to it. Because the carbon connected to the bromine was electrophilic, so that means anions were used. So we're going to remove 2 carbons, and then we're going to replace them by an electron pair. So we have 1, 2, 3, 4 electrons, because 6 subtract 2 is 4. And then finally we have the last, or technically the first reagent, which what did this do? Oh, this is a very strong base, so it deprotonated the electrons, which more or less means we would just get rid of the lone pair, and this would be our starting product. Now we have 4 carbons here. Now let's count them. D has 1, 2, 3, 4, 5. Cannot be that. C has 1, 2, 3. Cannot be that. A has 1, 2, 3, 4, 5. Cannot be that. So it leaves us with B. Has 1, 2, 3, 4, and it also has the alkyne here at the edge. Now, if it wasn't there, it could have also been on the inside, but since it's already confirmed that it's there, we know B is our answer. The second question that I have is question 8 of chapter 16, which asks, what step group polymer is formed from these 2 monomers? So this acyl chloride reacting with this alcohol, more or less, the chlorine is a good leaving group. It'll leave along with the proton, and then they'll just be joined there. So instead of an acyl chloride, it'll now be an ester, and then it'll continue the same pattern. So there's 1, 2, 3, 4, 5, 6, 7, 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8 attached to an OH, but this OH again will attach to react with another acyl chloride, and so the list goes on. And then let's see in the beginning, let's say if this one didn't react, then it would still be connected here. Nah, this would still react with an O. Okay. So now that we have our answer, let's look at the carbons in between. We have 1, 2, 3, 4, 5, 6, 7, 8 carbons, right? But remember, there's supposed to be an ester here. There's no ester formation, so B almost looks close, but it was not it. And then D, they also have 8 carbons, but they have the 8 carbons in the wrong spot. The 8 carbons are in between the 2 ketones when it's supposed to be between the 2 esters. So it can't be D. C, it has 8 carbons in between the ester and the, well, this would be another ester. They just cut it off. And they have the 4 carbons in between the ketones. So C is our answer. A can't be A because, well, there aren't that little carbons in between. As we mentioned, and it's also missing the ester, but the O separation, it's like just too short as well. I hope this was helpful. Thank you for watching.